Hi, my name is Yasuhiro Inami, and I'm so happy to speak in this Tri-Swift conference once again. Last time I came to in Tokyo, 2016, and I gave a talk about parser combinator. And this time here in New York, and actually I used to live here when I was 2 years old, like 2 years, so I don't remember anything. But to me, this is both memorable place and memorable event. So I'd like to thank Natasha and organizer team for inviting me here, and thanks for coming here to talk and listen to my talk. Today, I'd like to talk about new Swift for Codable topic, which was announced at this year's WWDC. By the way, I come from Japan, and I'm working at a company called Abema TV. Office is based in Tokyo, and we develop a lot of media apps, including this one. This one is a live TV show app. You can watch like TV series, dramas, animes, sports, and so on. And if you're interested in live streaming project, please contact me at any time. So let's get started. This is WWDC 17 photo I took in keynote. And I was lucky to sit in the very middle of the venue. And as we all know, this year's WWDC was a fantastic one. There was an introduction of ARKit, Core ML, and lots of other great features. And among those, evolution of Swift was also amazing. Swift team has announced Swift version 4, which you can watch the session video on Apple's website. The session 212, what's new in Foundation. In this session, there are many cool new features like smart key paths, Foundation improvements, and so on. But the most exciting topic was probably the Swift for Codable. And this is basically the replacement of old NSCoder in Objective-C, and we can convert Swift data value to the serialized format and vice versa. You can find the related Swift evolution proposals in SE0166, Swift archival and serialization, and SE0167, Swift encoders. Now, let's take a look at how Codable works. Let's say we have JSON. We want to parse this one into Swift. From Swift 4, we can now use the multi-line string literals like this one. You can make let JSON equal and yeah. And this is surprisingly indent-aware, and it's very handy and useful. Next, we create a corresponding struct myData, for example, and let this struct conform to protocol Codable. And one important part here is that all properties in this struct must also conform to Codable. And in this case, they are all OK. And then we use a JSON decoder to parse JSON string into our Swift data structure by calling try decoder.decode on the upper one. And also encode back to the original format by calling try encoder.encode. And you just get these results. So simple. I would say it's too simple that this is magic, Apple magic. This magic works for any data type that conforms to Codable protocol. Here are the list of Codable, built-in Codable. And you can see primitive types such as bool, int, strings are Codable. And also container types like optional, array, dictionary are Codable. And moreover, not only Foundation types, but recently, core graphics types like CGRect are also supported too. In the previous code, I just showed the JSON parsing example, but Codable can be used in any other formats, including CSV, YAML, binary formats, and so on. All we need to prepare is just decoder and encoder. And the Foundation already provides JSON and also as well as property list coding, which are backed by JSON serialization and property list serialization. So far, so good. Now, our next curiosity is, how does this magic actually work? And if you have already watched the session video, you already know the answer. It's auto-synthesis by Swift compiler. To recap the WWDC session, if we have a data structure like this code with Codable conformance, Swift compiler will interpret this as this code. You can see that quite a lot of codes are generated here. And I just added @derived keyword. This is just a dummy keyword to express that it's synthesized. And you see the 3 code blocks. These are important. 1 is enum coding keys. 2 is init from decoder. And 3, encode to encoder. Let's take a look at each. First, the first one here is the enum coding keys. It's a key type used to map JSON's raw string value to this enum, so that we can all grasp what kind of JSON keys are possible. And so it increases the readability, and also it makes the key more type safe because we are replacing the raw string value, which is untyped and unsafe. And second, init from decoder is the part where you are doing the decoding process. And we ask decoder to deserialize the data and store into Swift value, which is also become type safe. And lastly, the func encode to the encoder is just the opposite. You will give the Swift value and to the encoder, and the encoder will convert into its own format. So Swift compiler generates all these code for us, and it's very useful in many cases. But sometimes we want to customize this in order to apply to more complex problem. For example, can you read the code here? I want to map the JSON key that has a snake case rather than camel case. So in Swift, we often use the camel case letter, right? But if JSON has a snake case, what should we do? And so on. And also, we want to do parsing of the score int, but only want to filter from 0 to 100. Otherwise, let it fail. How to do this? We can manually implement our own coding keys, enum coding keys, and init from decoder, like this code. We can tweak the coding keys enum raw value, adding the camel case string instead. And inside the init from decoder, we can add guard statement and let slow the error if the requirement is not satisfied. So that's the end of the introduction of Codable. Now let's take more deep look into the protocol-oriented architecture. This is the overview of Codable protocol and types from Apple's slide. So far, we have talked about encodable, decodable, coding keys. But there are more important protocols, too. Let's take a look at each. First, actually, the Codable is just a mixed protocol of encodable and decodable. And you can see the top one, the ampersand here is the mixed protocol. You can now use this syntax in SwiftFlow. And each decodable and encodable will eventually add the function init from decoder and encode to encoder. We have already seen that. And the last protocol coding key is basically a replacement of JSON string value. But it's not only for JSON. It can be any other format. So sometimes the dictionary may have integer-based integer key. So this coding key also provides the optionally int value as well. And next is the protocol of decoder and encoder. And one important and interesting point here is that these protocols themselves do not decode or encode. But rather, they provide a hierarchical parsing mechanism, which is called containers. And let each container decode or encode instead. And there are 3 important containers available. One is keyed container, which is for parsing the dictionary representation. 2, unkeyed container, which is for array. And 3, single value container, which is for non-correction types, like bool, int. Let's take a look at each. For the first keyed, this is keyed decoding container, protocol. There's a protocol suffix in here. And it has a method declaration as follows. I didn't write everything in here, but actually there are I don't know, more than 20 methods, other methods. But basically, it's almost same as the func decode. But anyway, so we have a func decode to decode the value, the serialized data. And there's also an optionally parsing function called decode if present. And it also supports the nested container. It can create a nested container, like nested container keyed by or nested unkeyed container to parse the nested array or like nested dictionary. Also, there's a function called super decoder. This can be used for if the JSON has a superclass structure support, and you can create a super decoder and pass to the superclass's initializer and so on. And by the way, I just missed the name of this class protocol, but this protocol has a name protocol in the suffix. And there's actually a type erased version called key decoding container. So please don't mix up with these two. It says struct, type erased struct. And if you haven't checked the WWDC, if you haven't checked the Codable's code after WWDC, there's a new function called decode neo for key, newly added after WWDC. This function is used for supporting the default implementation of func decode if present. Next, we have a keyed encoding container protocol, and things are almost the same. One difference would be the func encode conditional. This was formerly an encode weak. And this is for encoding the reference type value, a reference encodable type. Now let's take a look at the unkeyed version, unkeyed decoding container here. This looks very similar to the previous one, such as we have func decode in present, and so on. And the one difference is the top 3 or 4, the count is at end, current index. And you can see these are the kind of internal states. And these are for, obviously, iterating the array of serialized data. And here's unkeyed encoding container, and pretty much the same signature. Last one is a single value container. And the top one is a decoding, and the bottom one is encoding. As you can see, the func decode, neo, and func decode are there. But please notice that there's no func decode if present. This is because single value container is basically for non-optional value only. And in addition, there are 2 enum errors available, decoding error and encoding error. These are well explained in WWDC session, so I will skip this explanation for now. So we have just gone through all important protocols. And especially the container protocols are the keys to understand the Codable. These 3 containers are keyed, unkeyed, and single value. And these are used for intermediate hierarchical representation of any format of decoding and encoding. And here are some other information I just added. So hopefully you are still with me. And our next question and the final question would be, how does this compiler actually, the Swift compiler actually synthesize the code? Aren't you interested in this? And this is very fun part because we don't no longer use Swift. This looks like Swift, but actually it's C++. So this is try C++ conference now. OK. So, but this is just a simple header file. We can notice that the Codable-related identifiers are listed in here. Coding key and Codable decodables are in the class called known protocol kind. And this is inside the known protocols.def file. And also, there's another file called known-identifiers.def. And it also has a functions name and so on. And you can see that they are treated specially. So because they are treated as a special identifiers, something much special is happening inside the compiler. And if you dig into the libsema's type checker class, you can see the magic is really happening in here with the 3 functions. One is derive coding key, and one is derive encodable, and the last one, derive decodable. For example, if you dig into derive encodable and derive decodable more, you eventually find this function called synthesize coding keys enum. As the function name tells, it will create private enum coding keys that conforms to coding key from scratch if it's missing. And here, I just abbreviate the code, omitted the code, but basically, you can see that there's an auto enum declare equals new allocating a new enum declare and so on. This part is basically you are creating a new name called coding keys, new enum coding keys, and that inherits the top one protocol coding key. And you also set the accessibility to private. And after that, you run the for loop, and you will create each case members here. So very straightforward. And here are the other functions. You might want to check this one, too. I won't go through all for now, because I don't have much time, I think. So, but if you have never read the Swift compiler code before, I highly recommend to check these functions as well, because these are well documented inside in the code, and it's good to understand how compiler actually works, how the compiler synthesizes the code. Even if you are not a C++ expert, it's very good it's good to study. So please check these out. And lastly, here are some thoughts I came up with when I saw this Swift4 Codable. Number one is, actually, many people are asking the same question, but why do we need type variables when we are trying to decode or encode? So like my data equal try equal to decode, and we put the type variable here. Actually, if we use a type inference and let return type to be inferred, we can write the code more shortly, like the bottom. Why is not Swift designed like this? And to answer to this question, Swift team member Doug Gregor already actually mentioned in Twitter, and he said it was a design choice to make things more clear and to avoid type inference magic. I also asked Itai Faber. He's a original implementer of Codable. I asked him in WWDC lab, and he also mentioned the same thing. It's good, easier for especially the new developer to understand the code. So they decided to make this decision. And my second thought is, can container actually be an enum-based rather than protocol-based? And here's why. This is the enum JSON, where you might see this kind of pattern many times in other libraries sometimes. And this is code I extracted from my previous talk. And I also made a JSON decoding library using this enum representation. And this is intermediate representation. So, and Swift4 Codable also provides the intermediate representation called container. So how about making the container into enum-based instead? And if I make indirect enum container, which is recursive, you can make a recursive tree like this. And one is a keyed container, and second one is unkeyed, and the rest of the cases are for single value, for example. And we also had func decode and func encode. And if we, for example, we implement the func decode encode to encoder, maybe we can write the code like this. Like it's very structured and like it's more declarative and functional. And I thought this one would be pretty cool. But actually, there's a problem when if I want to implement this one. And this is just a thought experiment, and this is not yet possible in Swift4 because this approach uses the generic case of enum. I added a warning mark on there. I use the generics inside the case here, but it's not the generics of the enum container. This is called higher rank type in type system world, and I'm not very good at that yet, but Swift doesn't still support these kind of features. So maybe if one day Swift supports this, maybe I can try this code, and maybe it can be fun things to explore. So sorry for the off topic. That one was just off topic. But anyway, to recap my talk, we have just gone through the Codable, new Codable protocol. And I would say it's Apple's offshore magic. And hopefully, since for 3 years, we developed over like 100 JSON libraries, right? So I think it's the end of that. And because, yeah. And for about Codable API, I just talked about enum-based stuff, but that's just a thought experiment. But I still think protocol approach is also great and beautiful in general. But I think also saying Codable can be more improved, such as Swift Evolution 0143, conditional conformance support. Do you know this? That's like you can make extension array that conforms to equatable, which element also conforms to equatable stuff. If Swift is going to implement this one in Swift 5, actually the Codable's code will dramatically be reduced in size and it's much simpler. So there are actually workarounds inside if you look at into the code. So I hope the conditional conformance will be supported in Swift 5 and makes things great again. So that's it for my talk. Thank you very much for listening.